Okay ครับ I think we're gonna start now just to review the thing that we learned from last week, and then we're gonna move on to the next chapter. Okay, so first of all, let me start from taking a look at the thing that we learned last week. So the thing that we learned last week is we learned how to deal with differential equations, and this is going to be the part that it's going to be tested by looking at the take-home exam. So what we learned last week is we learned how to deal with separable equation. We learned how to deal with um, homogeneous equation, and we also learned how to deal with exact differential equations. The thing that we haven't talked it's about the integrating factor. So well, we're gonna spend about 15 to 20 minutes here to talk a little bit about integrating factors, and this is going to be the last topic for differential equations, and then this topic will be on your take-home exam. So again, from last week we know that the differential equation is the equation that you both have dy by dx and x and y like in the same equation. So the thing that we learned last time, we learned the exact differential equation. So this is the quick theory for the exact differential equation. So let's do a review pretty quick here. So when you have the equation mxy dx plus nxy dy equal to 0, so you're gonna start by differentiate m with respect to y, and then you differentiate n with respect to x, and then you check if they are equal to each other or not. So if these two terms m diff เทียบ y and differentiate n with respect to x, they are equal to each other, so we're gonna call that the differential equation is exact. And once it is exact, you know that fxy equal to c gonna be your solution, and then you can solve for f here by integrate m dx or integrate n dy. This is the thing that we're gonna do for exact differential equation. So when I say differentiate m with respect to y, it means you differentiate with respect to y, but now you treat x as a constant. When I say differentiate with respect to x, you treat y as a constant. So sometimes you're gonna see the case that if you get differentiate m with respect to y and get n differentiate with respect to x, if they are not equal to each other, you can fix it a little bit by using the integrating factors. So this is the example that we have the exact differential equation last time, and then once you have exact differential equation, the solution is fxy equal to c, and then you solve by using f equal to integrate m dx or integrate n dy. In this case, I pick to do integrate n dy, which is this one. And remember last time I told you that when you integrate dy, you treat x as a constant, so do not integrate x. So x is constant, so you move it out here and then you integrate just only y. So this is going to be the part that it is a little bit in advance because you haven't learned how to integrate into dimension yet, but you can do it pretty quick by just saying that if you integrate with respect to y, you treat x as a constant. If you integrate with respect to x, you treat y as a constant. Technically, when you integrate with respect to y, you're gonna have some constant in term of x as well, but for this case, you don't have to be worried because the constant here, usually when you integrate, you're gonna have some constant, right? But because you integrate with respect to y, you view x as a constant. So when you integrate, you're gonna have a constant in term of x as well. Constant in term of x. Constant in term of x. But this time when you get the constant in term of x, you can double check that it is actually 0 or it has something in term of x or not by taking this function that you get, you differentiate with respect to differentiate with respect to x and check it is equal to m or not. So in this case it's going to be okay, because once you have this one, you differentiate this function, it's get back to m perfectly, so it actually means the constant is equal to 0. So you're going to see sometimes you're going to see that the constant is not equal to 0. You're going to see it in the clip. There is one example that sometime when you integrate here, the constant is not equal to 0. So please take a look on the examples in the clip. So today we're gonna do one more example that show you how to do integrating factor. This is the last one for differential equation. So let's do it. This is the one that we have left from last time. So I want you to solve for the differential equation dy by dx equal to this differential equation. So first of all, we're gonna simplify. So, well, for sure, this is not separable equation because you have x and y together here. So it cannot be separable. So you're gonna simplify it. So you get x squared plus y squared here, dy. And then you have minus 3x squared y plus 2xy plus y cubed dx here. So I move everything around. So I get this one. And then I can move the right hand side to the left hand side. So I get 3x squared y plus 2xy plus y cubed dx. And then plus x squared plus y squared dy. So the thing is that here you get this thing equal to 0. So this is in the standard form already. Standard form. Okay. This one is your m, mxy. This one is your n. This is your nxy. Okay. Once you get in the standard form, your mx dx plus nxy dy equal to 0, you start from differentiate m with respect to y. So I'm gonna differentiate m with respect to y. I'm gonna differentiate n with respect to x, and hopefully we get something equal. So the differential equation is exact. So we're gonna differentiate 3x squared y plus 2xy plus y cubed with respect to y. So this is pretty new to you. So what you're gonna do is you're gonna keep x as a constant. You only differentiate y. So here you're gonna get 3x squared plus 2x plus 3y squared. If this is too fast for you, think one more time. So 3x squared y, I will 3x squared as a constant. So I get that one. So y is just only our target variable. 2xy we're gonna differentiate with respect to y. So 2x is constant. So I get 2x. But here y cubed, this is variable. So we're gonna differentiate, we get 3y squared. And then differentiate n with respect to x. N is x squared plus y squared. So the thing that you have here, you get 2x. So you can see that the thing that you have here, the one in the box here and the one in the box here, not equal. So the equation is not exact. Well, when the differential equation is not exact, what you can do is that you can try to compute some terms and see if it get better after you do it. So first of all, we're gonna keep this thing to the I'm gonna carry this one to the next page. Copy. And then new page. Paste. Okay. This is from the last page. We're gonna introduce you something called integrating factor. The integrating factor say that if you compute differentiate m with respect to y, and then you minus differentiate n with respect to x, and then if you multiply 1 over n, if this thing is does not depend on x. So we're gonna let this thing called px. Once you multiply mu equal to e to the integrate px dx to the original equation, it will be exact differential equation. So the theory say that even if you have this one and this one, they are not equal to each other, okay? So they are not equal to each other, but once you compute this term, and if it does not depend on x, so you're gonna call this thing px. And then once you have this thing px, oops, sorry, did not depend on y, I guess. Does not depend on y. So we're gonna call this thing px. So once จอมันสั่นๆไหมครับนิดนึงใช่ไหมมันสั่น because มันสั่นเพราะอะไรวะแป๊บนึงมันรู้สึกมันสั่นๆแป๊บนึงมันสั่นแบบแปลกๆมันเหมือนข้างบนเขาคำได้หรอไม่ใช่เขาแบบมีกิจกรรมหรือเปล่ามีกิจกรรมการสอบ It's okay ไหมเนี่ย I think it's because of the air conditioning probably
It should not be because normally it doesn't happen right
จอไม่ได้สั่นจ้ะแต่ว่า
โปรเจคเตอร์อะ
ภาพสั่นจอไม่ได้
yeah
สั่น
จอไม่ได้สั่นภาพสั่น
อาจารย์เราต้องมาทำอะไรสิอะต้องมาสอบก่อน
Okay, so continue this one. So we have this thing does not depend on y. เนี่ยมัน shake อะ this is shaking. So it was like annoying me like
อาจารย์ can we change the rule impossible
มัน So we're gonna compute this thing. So first of all, we're gonna compute differentiate m with respect to y minus differentiate n with respect to x. It's keep shaking นี่ปวดตายังไงวันเนี้ย
ปวดจริงจัง
เปิดซูมไหมอ่ะ
อ๋อโอเค
ตามเปิดซูมไหม
โอ้ยโอเค get better นะไม่ better ว่ะokay let's keep going we're gonna just keep doing it then so we're gonna do 1 over n it's 1 over n here is x squared plus y squared and then differentiate m with respect to y this is actually 3x squared plus 2x plus 3y and square and then you minus 2x so you can see that we are lucky enough that this term 2x and 2x they cancel out so when they cancel out and then you only have 3x squared plus 3y squared over x squared plus y squared and this is actually 3 so you get the cancellation here so here you get 3 and then once you get 3 here so this is called px so then you compute mu equal to e to the integrate px dx once you compute mu equal to e in integrate px dx here so you're gonna multiply the equation with that mu and the equation gonna turn to exact differential equation this thing is called the integrating factor so the integrating factor is the term that you do e raised to the integrate px dx. So here you're gonna have e integrate 3 dx, which is e to the 3x. So once you have this one, you do not carry plus c, just keep e to the 3x. So this is called integrating factor, and the integrating factor here gonna be the one that when you multiply it to the equation, and then you're gonna get back the exact differential equation. So I'm gonna show you in a minute, but let some of you take the notes first. สั่นเนาะ
จุฬาลงกรณ์มหาวิทยาลัยครับคนละมากเลย
Okay, next one. So once you have e to the 3x here, so go back to our original equation here.
นี่ส่วนไหนเดินดูโอ้ยไม่ต้องสั่งอ่านไม่ต้องอ่านยาก
อ้าวนิ่งไงเนี่ย
ลงรอดูไม่เกิน10 วิ
มันเด้งก่อนเด้งก่อน
Okay, so we're gonna just carry the first equation here that we have. You can carry this one. Boop. This is the one that is in the standard form. You have m and n already. And then now you multiply e to the 3x to equation. The reason why you multiply e to the 3x to the equation, because this is integrating factor. For the previous step, you know that our integrating factor is actually e to the 3x. So we multiply it to the equation. So once you multiply it to the equation, now if you differentiate m with respect to y, and then you differentiate n with respect to x, it's gonna be the same now. So differentiate y e to the 3x, 3x square y plus e to the 3x, 2xy plus e to the 3x y cubed. So you multiply e to 3. Actually, you don't have to multiply it. You can just, this is actually a constant. So 3x square y plus 2xy plus y cubed. So you differentiate with respect to y, so you get e to the 3x. This is constant, you pull it out. And then you get 3x square plus 2x plus 3y square. This is differentiate m with respect to y. For n, you're gonna differentiate here e to the 3x, x square plus y square. And then this is actually the one that you have. You differentiate with respect to x, so you need the product rule. So this is u and v. So remember, differentiate is you get u dv plus v du. So it's gonna be u dv plus v du. Once you simplify it, you're gonna get e to the 3x, 3x square plus 2x plus 3y square. So now exact, because they are equal now. Does it make sense? So the term that you add here, e to the 3x, this is a magic term that you added into the equation, and then you differentiate. Now you get the same term here. So now the differential equation is exact.
อาจารย์ครับ
Okay, you can ask question now.
Okay, so normally, anyways, you should make the equation exact first, then you calculate for the answer, right?
Yes. So the idea is that even the original equation is not exact. we can transform it to exact differential equation by multiplying something. And the term that we're going to multiply is going to be e to the integrate px dx, where p is 1 over n differentiate m with respect to y minus differentiate n with respect to x. Okay. Once you compute that thing and then it's only in terms of x, you have the integrating factor e to the integrate px dx, and then you multiply it back to this equation, and it's guaranteed to be exact differential equation now. You don't have to memorize the formula because it's gonna be given.
For the first sentence in green, do we don't use product rule as
We can use product rule as well if you want to, but I just pull out e to the 3x out.
Can I compute the lower sentence like the upper one?
You're gonna pull this thing out.
Yeah, yeah.
You cannot because differentiate with respect to x.
Oh,
Yeah.
okay. Got it.
This one differentiate with respect to x, so you have to use product rule. But here differentiate with respect to y, this is constant, so you pull it out.
อาจารย์ครับ but let me ask you something so that will the integrating factor affect any answer or it just meant for the solve for the answer?
No, it does not affect any. It does not affect the solution because when you multiply e to the 3x, the right hand side is 0, so it's gonna be,
Oh, that makes sense.
yeah, so this term 0 multiply this thing gonna be 0 anyway, so it still give you the same solution with the original equation.
Okay, like nice, makes sense.
So once you have exact differential equation, you can continue your work as in example 5. And that will be the end of this question. So once you know that it is exact, so you can do your tasks like you did before in example 5, and then that is how we solve for the exact differential equation. So this is the end of the differential equation technique that you're gonna learn for this class. So be relaxed when you look at the clip because it's just like you don't have to memorize anything. When you get the set of problems, you can take a look at the video clips and do step by step. Take your time to do it. ว่าไงครับ
So the first thing that I should do when I face the differential equation, I should just answer myself that which type of equation that I'm facing, right? So if like homogeneous or like the separable equations, so just I have to know first what it is, then I just use a specific way to solve it, and that's it. Right?
Yes.
Okay, thank you.
So everyone, before we move forward, let me trying to explain to you here one more time. We're gonna continue the next section now, which is the limits and continuity. But before we move to the limit and continuity, so let's talk about differential equations here.
Okay.
So one more time, you're gonna need to watch 6 clips on differential equation by your own. So the example that we did in class, it's only one example for each one. So you're gonna need to watch the full video on the YouTube. It's checking, no? And then now, exam 3 gonna be 10% of your grade. It's gonna be about 4 to 5 questions. You can open your notes and clip, and it will be posted on April 5th and due on April 12th. So at this point, we are not going to come back to talk about differential equations. So it's gonna be the tasks that you're gonna study from the video clip and also do the exam take home. Okay, so everyone should expect to submit this thing by April 12th, and if you think it is easy, it's fine because this is a take home version, so it's, you should like complete it, like you can do it like all question because this is an open book thing, so it's gonna be the similar to what you have in the video clip. And for homework number 3 for the class, we cancel it because we're gonna do the take home exam, so we're gonna cancel the homework number 3. So the next homework for you gonna be homework number 4. Okay. So right now you can go to my course view and then you download the video clip. No, you download the not the video clip. You download the handout for the next section.
What
Level curves, limit, and continuity. We're gonna start in few minutes. So handout number 9. Level curves and limit and continuity.